Hello, Professor. Our project is Food Cost Visualizer and Planner. I, Akshay Bafna, along with my team, will going to present this. So I'll just quickly go through the table of contents. So we have client and project description, our team, and the project status and the timeline, various phases of our project, and some new ideas and challenges. So I'll not take much of your time as it's about Food Truck Association of Canada. It's one of the Canada's first ever national and non-profit association, which was supported by the advancement of food truck industries, and it empowers food truck businesses to succeed. So they foster a vibrant food truck culture, and it advocates for smart regulations and celebrate the unique flavors that bring to our community. So. I'm the project man and responsible for managing project communication between the client and team, and Yash Gupta, who's a data analyst, who's responsible for data cleaning, transformation, analysis, and predictive model using Python. And then Nikhil, who's a developer and is responsible for data storage using SQL Server and making visualization and dashboards using Power BI. So the status, it starts from initiation phase, which was in December last year. Then we went to the requirement phase, which was in the February, 8th of February. Um, then leading forward with the data preparation and analysis phase, which was around mid of March, and then the development phase, which was on track by the end of March currently, and the release will be in the mid of April. So I'll just go through with the requirement phase. So this is the initial data set, as you can see in the left hand side. And then we have categorized into five different categories, namely meat and dairy, bakery and the food. And the last one is the other food items. So these were the categories which we did. So this is the code for data fetch, um, as you can see, which will be incorporated later by my colleague. Then the data preparation and analysis phase. So this is the data cleaning and transformation which we did. So basically the detail will be explained by my colleague later on. So we have removed the irrelevant products and handled the missing unit and so on and so forth. And then the data loading and relevant data selected, as you can see in the code. We have imported libraries, and then we have cleaned and altered the data and renamed the columns accordingly, as you can see in the code. And then we have standardized the measurement system and changed the data types. Then there was a requirement from our client that we need to incorporate according to the NAPCS system. So this requirement we did it in the middle phase. So the sheets, as you can see, there are items and the NAPCS code accordingly. Then we have combined all the sheets into a dictionary. Code is mentioned here. Then what we did is we created and stored these dictionaries into an SQL database. Then the most important thing, that is the development phase. So we have some research model. Currently, we took three research models, and then we built and evaluated these models and later on saved it. And then the dashboard, as you can see by the example, we have selected some of the meat categories, namely bacon and tuna, and the visualization being presented with the menu item, which is one of the most important in scope here. And then my colleagues, they're going to explain the later stage of the coding and all.
Thanks, Akshay. Hi, Yash here. So, I will be presenting the technical and coding side of our project. So, this is the dataset that we selected for our project, monthly average retail prices. As you can see, this provides monthly data, monthly food prices for each of the products. There are around 100 products which we are getting. So, we are fetching this dataset using the Python library provided by StatScan only. So this is the official dataset that we got. As you can see, there are many missing values and some irrelevant columns. So what we will do is to clean this. This is the cleaning file that we implemented. First we are loading the dataset. Then we are selecting only the relevant columns. After that, we are properly typecasting it and checking those products. As you can see, the products, their unit measurement and their quantity is already consolidated in one column. So what we'll need to do is to separate them. So after separating them, we'll rename them properly. As you can see, we have successfully extracted the products from the column. After looking at this list, we can see there are some unnecessary products that are not needed by food truck operators. So we'll just remove them from our list. After that, we'll convert our dates or months into the season they fall in so that it can be categorized for better analysis further on. After that, we'll see that a product tea bag, it will have an exception because it will not have no unit, or it was not separated using our previous method. So we'll need to implement another function for it. And after that, we can see there are no null values, and we have got our product list. After that, what we can see is in a unit column, the measurement and the quantity is consolidated into one, and we need to handle this also. So this is how we handle that. And after converting them and properly typecasting it, what we can see, there are too many measurement systems. So what we have to do is to standardize into an SI measurement system using this function. Now we can see there are only 4 measurement. Now we'll just properly typecast them and save them as a cleaned MRP. So after cleaning, this is the data set that we got. As you can see, this is much more sophisticated as compared to our original one, which is this one. And when doing some analysis, we find out that there were too many data points and there was too much difference in them. So the data need to be standardized furthermore. So what we did is to convert our liquid products that are whose measurements were liters and all, and the single unit products into one single category, that is kilograms. So we did some math and made this function so that it can be handled properly, and created a new standardized data file. So if you'll see, this is the new column that was added. Uh, so the price, as for example, so price for bacon for half a kilogram was 503, but for 1 kg it should be 1006, which is now standardized. Now we can move further with the analysis. And after analysis, we did use 3 of the time series models for predicting further prices, which we'll show you in our final presentation. And now Nikhil will show that dashboard of ours.
Hi, Nikhil here. So I worked on the development of this dashboard, and we created this in Power BI. So quickly starting, I'll go into the model view. So currently in our dashboard, we are fetching the data from multiple sources, which is SQL Server and Excel sheets. So this query one, as you can see here, this is being fetched from SQL. This is in our local database, and this will have the products and their price. Also, the thing here is that the price that we have of the product is based on different quantities. Like, let's say one product has been shown in uh, per kg price, and the other product has been shown in like per half kg or something like that. So we standardized it using our SQL procedures, and then we have this item with codes, and this sheet, this is coming from an Excel file, and this has the item and its NAPCS code in it. Then we have this classification 2 sheet. This has the products and their category that they belong in. And then finally we have this sheet one. This sheet one, it has the forecasted price of the products. Now back to report view. As you can see here, this dashboard, it consists of slicers, cards, and charts. So I'll start with the slicers, and let's say if I pick few categories here, I'll select meat and fish, seafood, and these are the categories that I have selected. And from here, if I select bacon, then canned salmon, then beef, strip line cuts, and I can select salmon. So these are the products that I have selected, and as you can see here, this is the line chart. So this has the products in legend, and we have the price by date, and on the y-axis you can see the price, and on the x-axis we can see that we have the monthly data here. So for individual products we can track the price at that particular month. And then we have this another stacked column chart. This will have the list of products and their price. Then we have another line chart. This is divided into multiple sections, as you can see, based on the product. So for each product we'll have a single chart combined in it. So bacons, beef, salmon, etc., etc., we have it like that. So if we add another product, it will increase here. So you can slide down and see. So here what we have is like the expected price in the coming months, like a forecast of the products. So in January we can expect this much price for bacon, and similarly like that for all these products. And then we have this card for menu items. This will show us the list of items that we have selected, and then the final card we have here is this will give us the combined price of all the items that we have selected. So this is the prototype that we have shown to our client, and he suggested a few improvements and changes in it. Like starting with, he said that here, instead of just having the data based on the current maximum year, we can show the data for all the years that is present, so starting from 2017. And he also requested us to divide it in the seasonal format, like winter, summer, autumn, so that we can show here just by adding a drill down function. And then he also asked us to prepare a calculated field where we can give the input, and for a particular product we can calculate the price based on that uh, input of quantity that we have given. So currently this has been done, like we have given the we have set predefined the quantity fields. So here, instead of predefining it, we have to provide a manual input so that user can predefine give the input accordingly for quantity, and the price can be calculated. So this is the overall dashboard prototype as of now, and we're going to work to improve this in future. So thank you.
Thank you, Yash and Nikhil, for the detailed explanation. Now we'll go back to the theoretical cost, as we have allocated total budgeted hour, that is 34 hours with 50 cats per person, comes out to be 1700 per person. You can see in the graph about the detail hours allocated. And then so we have some of the challenges, namely like finding the proper data set that suits the client needs, then proper cleaning of the data set for best analysis. Then we need to find some of the suitable model for prediction. And the last one, that is it's basically the Power BI limitation for some calculated fields. Thank you so much for listening to us, and feel free to ask any questions.